Dear students, let us study one very important concept related to gravitation, that is free fall. Every object is pulled by the earth towards itself, but when the object moves under the influence of gravity only, then it is said to be falling freely. When body falls in the air, there are three types of forces acting on the body. First one is gravitational force, which is due to the earth and it acts in downward direction. Second force acting on the body is known as force of buoyancy, which is force due to the air. It is also known as upthrust, and this force acts in upward direction. Third force which acts on the body is the force due to the friction of air, and this force also acts in upward direction. An object is in free fall if and only if its motion is limited to the following conditions. First condition is gravity is the only force acting on it, and second condition is it is moving up or down. All objects dropped from a height fall towards earth. This happens due to the gravitational force. Suppose you have dropped simultaneously a small stone and a piece of paper from a height. Which of the two will reach the ground first? We see that stone reaches the ground earlier than the piece of paper. The great scientist Galileo showed that all the bodies, whether light or heavy, fall with the same speed towards the earth. Then, why stone falls earlier than the paper? Galileo showed that lighter bodies fall with slow speed due to the resistance of air. Galileo also proved that if the surface area of the object is more, then the resistance offered by the air is more. Thus, according to Galileo, all objects, whether light or heavy, falling towards the earth, fall with the same speed. But air resistance and the surface area of the object changes its speed. Later on, Robert Boyle proved this experimentally. He placed a feather and a coin in a long glass bottle. He evacuated the glass bottle with vacuum pump. Robert Boyle observed that when glass bottle is inverted, both the feather and the coin reach the bottom of the tube at the same time. Thus he concluded that acceleration produced in all freely falling bodies is same and not depend upon the mass of the object. Thus, when object is in free fall, object falls under the influence of gravitational force only. We know that gravitational acceleration g is equal to g mm upon r square, where g is universal gravitation constant, m is mass of the earth, r is radius of the earth, and value of g is 9.8 meter per second square for the object near the surface of earth.